Welcome to Open Hardware Talks, a series exploring the ecosystem of open source hardware. This talk is part of the Hardware X podcast by Elsevier, and I'm your host and editor, Miriam Gradell. Today's topic is discoverability in open source hardware. Open source is often presented as a method for democratizing innovation. And the notion is that because knowledge is shared freely, many collaborators can pool resources to drive innovation rather than individually reinventing the wheel, so to speak. In practice, however, the wheel is quite often reinvented because the problem is, how do you discover the many other people out there working to solve an issue similar to yours? So in this Open Hardware Talks Roundtable, we're going to dive into discoverability. We're going to take a look at what tools exist or are being developed to enhance it, and what benefits or possible risks arise when you make designs more discoverable. And to help us do that, we've got Victoria Jacqua, Robin Vabruba, and Nathan Parga with us. Victoria Jacqua is the medical community lead of Open Source Medical Supplies. It's a nonprofit organization that collates and shares open source medical designs. She's also a product owner and steering committee member with the Global Distributed Tracking. And she's previously contributed to this podcast in an episode on 3D printed tourniquets for Gaza and Ukraine. Robin Vabruba defines himself as a hacker and has extensive knowledge of open source and software development, some of which he has used to refine the library of open source hardware. And Nathan Parker is co-founder of the Internet of Production Alliance and currently leads the development of the Open Know-how, which we will also hear more about in this episode. And Victoria, maybe if you can start us off, curious to understand, how does discoverability relate to open source medical supplies that you're involved with?
Well, to answer that, we have to go back to the ancient times of 2020, specifically the 5-year OSMS anniversary that just passed of March 12th, 2020. And the organization was co-founded by Guy Cavalcanti. And there was a Facebook group that originally was focused on building an open source ventilator. And within 72 hours, quickly switched to PPE due to the enormous lack of PPE for healthcare professionals that we surveyed. And this was a really critical point in open source hardware history, and not just because of the pandemic, because before this date, the idea of an open source medical design was something that you just didn't really hear much about. There were organizations and universities always doing research on open source medical hardware. Most notably, I believe GLIA, based in London, Ontario, comes to mind. But it wasn't a concept that was known on a wide scale. And OSMS was an organization that globally put out the call for the creation of open source PPE designs and other open source medical hardware. So there was this surge of interest to create IP that was going to answer this call. Because of this, we had a surge of interest of designs, researchers, engineers, all convening in our Facebook group around this topic. And it was an incredible time. So much information was being shared. There was so much collaboration all around the world. And designs began to surface. Most notably was the Joseph Prusa face shield. When it was approved by the Czech Ministry of Health, everyone suddenly had confidence that they could make a face shield that worked because of that design, and then it was approved by the Czech Ministry of Health. And then the NIH uploaded that design, actually a remix of it, the DHAM face shield. And face shields were even more popular, and people began to feel even more confidence that they could design something that was usable. So remixes and different versions of this face shield began to be created, and this confidence and like innovation really spread to other designs. Well, if you have all of these designs coming into a Facebook group, how do people sort through them? How do they keep track of them? And this is where OSMS came in. We collected these designs, matched documentation, often developed relationships with designers or engineers or research institutions, and then curated them into our OSMS project library, which still exists today. These are not designs that OSMS owns. These are external links to that IP that we simply curate, so they are more easily searchable. Because when you have a vast amount of information, how do you organize it so people can have accessibility to that information? So that was our first goal, developing this project library. Over the years, we have seen that this idea of open source medical hardware remains very stable. This is not just a 2020 experience. And personally, myself, I am constantly meeting new organizations, new innovators within the open source hardware realm, and I have no idea they exist. I have no idea this amazing project is happening, and I would love to bring their design into the OSMS library. So over the past, I would say 2 years, there's been a greater focus on how can we build an infrastructure that is going to allow widespread discoverability of open source hardware, with perhaps the OSMS library as an inspiration, but expanding even beyond medical designs.
Yes, and I'm also very curious to hear from Nathan, and perhaps Victoria, you can also add to this because I know you've been involved with it as well. But part of what came from COVID was the open know-how, and I know that that also relates from the case of ventilators and the issue of creating a ventilator during the COVID. So maybe Nathan, if you can start us up, what is the open know-how? How does it increase discoverability, and also, how did it came into be?
Yeah, of course. That's just wild being reminded of the early days of OSMS. Spent a lot of time on that. So open know-how as an idea had existed since, I want to say, about 2018, but it was much more theoretical in the early days. But essentially the idea was looking ahead at something like what ended up happening in 2020 and knowing that it was a possibility, which is to say, the global manufacturing supply chain as it currently exists is fine in a steady state world, which is not what we live in. If the price of fuel and geopolitical relations and the climate are all stable, then getting whatever it is that you need from a mega factory somewhere is probably going to be the cheapest way to do it. But that's not the world we live in. And supply chains are brittle, and when under stress, they shatter. And the people who desperately need things at that time are out of luck. People who live at the periphery and the edges of the supply chain are out of luck, and so they need to be able to make the things that they need when and where they need them. And this is a problem that we were looking ahead at and thought, okay, this is the digital infrastructure problem. We don't need yet another Thingiverse. We don't need yet another platform that's just serving proprietary data. For all the obvious reasons. I don't think we need to belabor that point. The notion was, for a truly open source ecosystem to thrive, there needs to be a data layer that can encompass everything that is required in order to build a given object, which is a hard problem. If you had to think off the top of your head, for any arbitrary physical object, what is the list of things that you would need to know in order to make it? It's a non-trivial problem. But we've been working on it for a long time, and I think we've made a lot of progress. But essentially, the notion, as it relates to the ventilator project, and as it relates to sort of the crisis in 2020, a big part of the problem was both discoverability. There was, while OSMS was doing all this great work, kind of collating things, hundreds of different groups of engineers around the world were all sort of trying to reinvent the wheel, and wound up not just having to start designs from scratch because it was easier than finding the ones that already were in progress and improving on them, but also building their own infrastructure for hosting those designs, for checking and verifying them. Many of the designs, especially for ventilators, would have killed people if they had actually been applied in practice. And as a person who might have been trying to find one that you desperately needed, you had no way of knowing if this one was tested and safe on humans or just someone's random idea. Um, and the best option you had at the time was essentially like, is this on a website I trust? Is that trust transferable between the person that I know who's involved and this design? This is not a great way to handle things that are important. And so, there's sort of this additional layer on top of, can a data standard hold everything you need to know in order to build an object, but can it also hold information about, is this object safe? How, to what extent has it been tested and verified? Can we bind that information together in a way that is, transferable? Because what you want when it comes to anything more significant than, I 3D printed this Star Wars toy for my nephew, anything more important than that, especially medical supplies, you want to know, is this safe? Is this tested? Is this version of this design the one that actually works? You would frequently come up against this problem of, well, okay, the CAD file, is on the 7th revision. The documentation is on the 3rd. I don't know if this is actually the right thing, because all this information doesn't move as a unit. So all that is to say, Open Know-how is meant to be a universal open hardware data standard that solves this problem. And in particular, it solves it in a sort of what's the word? It solves it in a way that is sort of interlinked with a couple other data standards. The goal being that you want to be able to say not just what is everything you need to know to make a thing, but where can that thing be made? Because otherwise, this is just an abstraction. So you want to be able to say, for a list of facilities that can produce things, makerspaces with 3D printers, small scale manufacturing facilities, this guy's workshop in his garage, this research lab at this university, whatever. What are the machines they have? What are the capabilities they have? What are the materials they have access to? So when a crisis hits and you're like, okay, we need 10 of these open source ventilators within a 30-mile radius of this city now, what are the places that can make them? And just have a match of the shape of this design, the shape of this facility. Go, okay, great. We're, all we need to do now is confirm that you are interested in doing this, and we're off to the races. And that process would save, days, if not weeks, of back and forth and email and calling around and like, okay, what place can make this thing? And often in that time, either the need has passed or the crisis has gone beyond what you can solve with that thing, and it's the window's closed. So being able to act rapidly and handle that kind of automated matching of, what's available, what do we need to make it, where is that possible, and start that process as quickly and smoothly as possible.
Yeah, so it sounds like there's a lot of different data elements that needs to come together in order to solve this issue of discoverability. And I suppose, as you also said, I mean, also standards for the data itself, documentation, and all of these things. And maybe, Robin, since your focus lies a lot, or you've been a lot involved with LOSH, the Library of Open Source Hardware, maybe you can talk us through kind of what LOSH does and what is the technical aspects of ensuring discoverability.
Yeah, LOSH is the same like OKH, Open Know-how. And yeah, I'm doing the technical stuff. And early on we tried some technologies, and soon we came to RDF, or the open, the OWL, which is basically the format of so-called linked data standard. And I always think of it as like, what OKH really is like a database schema for a distributed database. A database schema is something that defines for a given set of data what tables do we have and how does the data between these tables relate to each other. And this is for a distributed database, which means data is all over the place and stored in different systems. It could be Thingiverse or GitHub or all that stuff. And yeah, that's in general it's a harder problem because of course the data is always dirty and different people will fill out the data, or some of it is automatically generated. Then there are different versions of the schema, and we have to try to find ways to port everything to the newest version and things like this. Yeah, and on top of that, we also have the problem that RDF is mostly, let's say, used by academics, and lots of the tools are also developed by academics, which let's say the software is not very reliable. Often it is developed within half a year and then not developed anymore, and by now lots of it is 10 or 15 years old already, and it's just done to fulfill the needs of publishing paper, and then it's gone. And so we also have to develop like very basic tools for using it for working with RDF. And yeah, I think I got lost somehow. maybe yeah, you can take over.
Maybe, yeah, Nathan,
Thanks,
do you
Robin.
want to go on? Because I know you've been also looking at this.
Yeah. No, I wanted to thank Robin. He's been a great help in working on this over the years. A lot of the work on this has also been going on under another group that started right around this time, 2020, called Helpful Engineering. And so there's been a lot of back and forth with us and Robin on this. I guess I don't know, I don't want to belabor the point. I think how to put it, what's happening with open know-how and sort of the open knowledge framework in general as sort of this, like the class of interlinked standards that make this whole idea possible, is I think the critical thing that I haven't mentioned yet is, a standard by itself is not helpful. There are plenty of standards out there already, and if you just say I've created a standard, fantastic, you have now solved the problem of there not being enough standards. That's the only problem you've solved. There needs to be tooling on top of the standard, and that's really, I think, the biggest push that's happening right now. Is even if you put a bunch of designs in this standard, in and of itself, that doesn't do much. So we're building tools that allow you to convert your existing designs into this standard, or to clean and validate it, because you have a bunch of stuff that's hand filled out and sort of in natural language and it needs to be machine searchable. Building out tools that allow you to kind of perform that matching that I was talking about, of saying, okay, for a given place with its production capacity, can it produce this thing, or at least can it get us to a short list from a long list so that we can manually take it the last mile. It's unlikely that this is all going to be perfectly automated, but even just reduce the amount of human interaction that you can reduce saves time, and that time saves lives. So the push right now is really to build the tooling and the sort of like the engine on top of this.
And so to understand, that's also meaning a sort of a more easy to understand or work with interface for people when they want to document their hardware. Yeah. I guess as it stands now, what are the things that open source hardware developers need to know when they're thinking about, okay, how do I make my design more discoverable? How do I make sure that more people can get to it? Potentially, how do they align it with the standards and the measures that you are working on?
It's a tricky problem, and I think we've all kind of approached this in different ways. I'll try to briefly sketch out one of the ways that I'm approaching this, and then I'm sure Robin and Victoria have other ideas. Again, in the spirit of this being open and not trying to recreate yet another centralized repository, yet another Thingiverse, we've been trying to solve this in a sort of federated approach. So the idea that I've been developing, I'm sure I'm not the first person to have it, but the idea that I've been developing is essentially, use existing infrastructure that just about anybody who is technical enough to build an open source hardware design is also technical enough to use, which is GitHub or some public Git repository. Barrier to entry is fairly low. There's a lot of infrastructure built there already. And the idea is essentially you say, okay, put your design in GitHub. If you want it to be searchable, make the repo public, and put in essentially like a flag file. Like it would be a blank file with a special name that only serves as a sort of a little flag, so that a crawler that goes across all public repos in Git can look for and be like, this is an open hardware repository. Suck that up, add it to the list, and then that gets kind of consumed and processed into a way that can be sort of republished anywhere else. So this allows you to say, like, all right, I'm running a page that is rehosting, say, open source medical supplies. I want to tweak the settings on this crawler to look for anything that is an open know-how sort of compatible repository that has the tag medical in it, and just pull back all of those things, and then I can render it on my page using this standard format. So that is kind of the approach that I'm taking. Robin and Victoria, if you want to jump in, I'd love to hear what your thoughts are.
Yes, it's actually something I've been working on a lot the last 2 months, is this crawler, or as we can now call it, scraper. The main issue there is that, well, it works very well for projects that, like for project hosting platforms that are really focused on open source and just want to help people and sharing and all that. But the other platforms like GitHub or Thingiverse, which are commercial entities, they don't have an interest for us to crawl them and get all their metadata, basically. And they make it very hard to find these projects, even if they have a flag file. And that's something, it's an issue, let's say. We're looking for solutions for that, but basically go to other platforms.
Yeah. Isn't GitLab a little more open source friendly? Ish.
I mean,
No.
they're open source friendly, but not for searching. Like they always limit their search capabilities in a way that makes it basically impossible. You cannot look for names of files, and even the searches you can do, you can only get at most 1,000 or 10,000 results from these
right.
hundreds of millions of projects. So
yeah, that's a problem.
And I guess I'm curious to, first of all, I'm surprised because, within the open source community as well, it's really GitLab and GitHub that is, the community platform. But I guess I'm was curious to understand whether you've had a look at, for example, Hardware X, and whether there's a, will these tools, Losh and Open Know-how, also be able to refer to Hardware X files? Has that been something that's been looked at, or is that still a possible?
I honestly wasn't aware that Hardware X had its own sort of proprietary format.
Same.
Yeah. I mean, the notion is that this is universal, and so part of that roadmap is as the sort of the base standard is developed, there will necessarily need to be kind of translator functions for all the ways that we find these things in the wild. So, Thingiverse has its own format. Hardware X has its own format. So kind of building essentially a parser that can say, okay, for an OKH can and must by definition be compatible with all of these systems. So we just need a system that can parse Hardware X, that can parse Thingiverse, etc., and convert it into this, and then share that back to the people who are hosting it, and just say attach this new open know-how file to your Hardware X, and now it's compatible. So the goal is interoperability, but I have not looked at the Hardware X sort of ecosystem, though I would love to know more about it.
Yeah, I mean, I'm interested.
Yeah, I guess also that's a part of the ecosystem. I think especially when it's an open source, there's so many doing so much, and it's interesting to explore it and make those connections.
Absolutely.
And moving on, I'm curious then to understand, since OSMS was made and open know-how has more kind of materialized as well, what are some of the benefits we've seen of this increased discoverability? I don't know if maybe you, Victoria, kind of as apart from OSMS, would like to share.
I think, although the surge of interest, of course, is not the same as it was in 2020, maybe from the a short time period between design to execution. I'm seeing that there is more of the acceptance that open source designs and their discoverability bring stability to the supply chain, even if it's only in a low resource area. It allows communities to perhaps be better prepared for unexpected events. And because there's a really diverse community in the open source hardware world, you often have instant friends. If you are designing something open source, there's probably going to be people who are interested in helping you and saving you time and sharing information so that you can get to execution level with your design more quickly. I think that the more we develop the unseen infrastructure behind a design is going to be really critical to further adoption, because when people see something that's 3D printed, that's open source, they're like, oh, that's cool. I can go print that, or I can use my laser cutter for that. That's like 1% of the entire process. There is so much work and thought and infrastructure that exists behind that design. And honestly, I'm hoping that this focus on ecosystem infrastructure and connecting all the different nodes within the open source hardware community will result in increased funding for these infrastructure projects. Because I see open source hardware filling a very critical role as a public service. And as we know, public services are increasingly under threat for accessibility. And instead of, public or, that's public's not the right word. Instead of government or private sector solving problems, I believe there is a third pathway, which is right down the middle of the road, and that is open source. And this can be the new public service, town square, where there is an infrastructure, standards, and protocols that bring not only good ideas to the front, but also support ideas that maybe aren't developed yet, that haven't been discovered, and we can help those be discovered and become part of the whole.
Well said.
Yeah, democratizing access to innovation, in a sense, right? I think it's a beautiful thought, and to try and play the devil's advocate a bit. I was also curious to understand what are some of the dangers and risks associated with increasing discoverability of open source hardware. We've already had one mention. I think, Victoria, you were the one who said, some of the hardware designs, or Nathan, maybe it was, for the ventilator, weren't safe when they were in the state that it was. And we are also seeing something like 3D printed weapons, open source files for this. So if we make these things more discoverable, what are some of the associated risks, and potentially what are ways to mitigate some of the risks it might be?
It's an interesting question. I mean, I feel like that goes in two very different directions. They're both about risk of harm, but one is risk of unintentional harm because you have a design that you're relying on for something important, something potentially life-saving, and it's not actually going to do that thing. And you don't know until you've committed to building it and using it. That is very much one of the problems that we've been trying to solve this whole time. There is, on the other hand, there is ways of open sourcing technology that allow you to intentionally do harm to other people, which is a very different problem. And that I'm not sure how to solve that one, to be honest. I think if human history has shown us anything, it's that when someone is determined to harm someone else, they will find a way. Sadly, in the former case, at least, that problem we can try to solve, because in that case, people are generally acting in good faith and they're trying to do the right thing. They just need the information in order to do that. And so that's where you can look at things like, say, okay, for in terms of data structure, think about you're searching through, say, 100 OKH files for a ventilator. There are relevant tests and certifications that a medical device can, and in many cases must, pass in order to be usable in a certain way. And saying, okay, this specific version of this design that has that is very tightly bound to this specific set of instructions and these design files and so on, is also tested and considered safe by this standards body. Any other version is not. Being able to have that information bound into the sort of the total design file and searchable makes a huge difference. It is a non-trivial problem to solve, but it is something that we've been working on. I don't know what to tell you about the 3D printed guns.
That's. I think if you had a solution, it wouldn't be an issue at this point, right?
Ask Shinzo Abe about that.
Yes. So I don't know, Victoria, Robin, if you have anything you wanted to add to the question of dangers or risks associated with discoverability?
Honestly, I think the more hardware is discoverable and labeled and categorized will actually make it safer. Because if I see this little valve, floating around on the internet, and someone says that it can function as a PEEP valve, and I don't know anything about PEEP valves, but I want to try to help my local hospital who needs them, I don't know except what that person said about that design. But if there are 50 valves that are categorized within an OKH, and I'm able to surface the one that has been studied and published as meeting certain requirements for safety, then I'm probably going to choose that one that has been peer-reviewed published as being safe to print. But if I don't know how to find that one paper that talks about that one valve, I'm not going to know that someone already studied that, and I can use this design. So the more we are documenting these designs with an OKH is actually going to cut down on, I think, safety infractions, because we'll be able to identify what designs are in prototype or have not been tested or have not been trialed. It'll be easier for people to do risk assessment for the type of projects that they're doing.
And Robin, I see you nodding. Maybe you wanted to say the same.
No, but it's very good. It's very good. So I'm much more on the technical side, and so we actually have an issue that's exactly about this topic. And so for me, it's also very important to, even though there are these concerns, we have to make sure that there's not some central authority that can censor everything. And well, one way of solving these issues is that in the standard, we would, that was my idea, to put fields or properties into the standard so that projects can self-label, saying this is a weapon, or this is a medical device, and it has this and this level of like stability or safety and so on. I think that's the first thing we should do. And then, of course, there could be bad players or people just omitting this information. But then again, omitting this information for a medical device would already give you information that's probably, yeah. So that's one way of going by it.
So actually, we've rounded a lot of the topics or the questions that I thought were relevant to discoverability in open source hardware, and I want to thank you all very much for your input. Before we round off completely, I would like to hear from each one of you what is next immediate step on what you're working on. Maybe I don't know, Nathan, if you want to go first.
Yeah, I'm working with helpful engineering pretty actively these days on what we've been calling the sort of open matching engine. Kind of the notion that I just spoke about earlier, where think about it like a sort of layer diagram. So standards at the bottom. On top of the standard, you build tools, like very simple, low-level command line tools that do one thing but do them correctly. Generate an OKH from this file, match an OKH to a thing. From those tools, you build an engine. This is something that gathers all these tools together, and that's where you can actually start getting other people to really play with it. On top of that engine, you build services that allow a website to call that engine and do stuff, and then send the response back to the website so people can kind of interact with it in their own way. And then in theory, above that, you have a platform where everything kind of comes together. But that's very far off. At the moment, I think the engine is kind of the minimum level needed for getting this really into the hands of people who can play with it. People who are doing open source hardware design don't need to also understand data structures. They just want to be able to work with them. So making the tools that people can use to work with these standards is really the big push right now.
Lovely. And maybe Victoria, you want to share as well, what is the immediate next project that you're working on?
For the past few years, OSMS has collaborated with Public Invention to create a new organization in the open source world called the Global Open Source Quality Assurance System. And this organization focuses on supporting tools that are going to increase trust, quality assurance, and safety within the open source hardware world or software world, largely focused on the medical and humanitarian niche. So we've developed a product under that organization called Global Distributed Tracking, which is a fully encrypted platform that allows safe and secure data management. And I could go into it, but we're very focused on safety and quality assurance, and how do we provide tools to the community so that they can track the movement of their device, of their shipment, or just of their data. Let's say you're a researcher in the field and you need a very quick way to securely document data that you're researching. Well, this platform is something that you can use for that. So this infrastructure that we're building, along with the OKH that Helpful Engineering and IOPA and Losh are building, we see this as a really rich environment for creating trust and accessibility and quality assurance. We're all working in small teams across a distributed platform, but the mission and the goal is all the same. How can we increase access while also proving not just what is good, but what stage of development this project is in? And from there, people can be informed. So I think it's actually a really exciting time to be part of open source hardware and software.
Yeah, I completely agree. And I think you said a very good keyword, which is trust, right? The openness and transparency that comes with open source hardware, and building trust in the tools and the services that are out there. And then maybe finally, Robin, you want to share what is your immediate next task ahead?
We have a funding project going on, and within that, until the end of March, we have to do most of the work. And that's building basically some basic tools for working with RDF ontologies, which is basically what people that develop interlinked standards need to ensure the quality of their standards. Yes, that's what we're working on. And we're also working on the crawler or the scraper. It already works well for Apropedia and OSHWA. Now, at the moment, we're crawling Thingiverse. And yeah, I mean, that's like what I took from this call is we need to support more platforms, apparently. Hopefully we can, well, start with hardware and also include hardware X at some point.
Yeah, I think that would be wonderful. You know, the more the ecosystem can come together, the better we can all push for it. So with that said, I want to say thank you very much to all three of you for joining us today and for sharing a lot of things about discoverability. And best of luck with your work from here on.
Thanks so much. Pleasure to be here.
Thank you so much.
Thank you.